Okay, this is number 3 on page 199. It says to enter values into the table so that table A represents a linear function and table B represents a quadratic function. Show that your answers are correct. So I'm going to go to some paper, and we want this to be linear. We want this to be quadratic. Okay, so let's start with linear. I'm going to use consecutive x's. So let's start with -2, -1, 0, 1, and 2. So first of all, does this pass the function test? That all x's are unique. Yes, it does. All of the x's are different, so we're off to a good start. Now, I'm going to go ahead and do this the graph way. So draw yourself a coordinate plane right down here. And I'll tell you what, I'm going to do something else too. Let me just take a picture of this. Bear with me just a minute, please. Let me do this. I want to cut these apart. So I'm going to crop that. I'm trying very hard to conserve my space. So let's get rid of this one. That's pretty. And delete that out. And then bring this table up here so that I can put a graph right beside it. Now I'm going to use the graph to generate my f of x's. Okay, here we go, iPad. Alright, this is what I'm looking for, kinda. So, let's pick a point that will work on this graph. So, -2, that's back 2 from the origin. Let me get on an actual line. So we're going to go back 2 from the origin, and I'm going to go down to 4. Let's just put it, I'm just making these up. Doesn't matter. But back 2, down 4. So that'll be the corresponding y. Then back 1, down 2. Let's use origin, 0, 0. Over 1, up 2. Over 2, up 4. And there is a lovely linear equation. It is 1 to 1 because all of my values are different, except I left my negative off again of that first one. It should be a -4. Back 2, down 4. So this is a function. It is 1 to 1. And let's graph it. It has a positive slope. It's kind of wonky. It's because my graph is not perfectly straight. Well, that's pretty good. Okay. So there is a linear equation. Now let's make a quadratic equation. So let me crop this off and we'll get table B. And I'm going to ask you on this one just to trust me that the values I'm giving you are correct. So for the x, let's use, actually let's graph it. That'll be easier for you to see too. So let's do a line here and a line here. And I want my y-intercept to be up here. So this is the point 0, 3. And let's put it in right here, 0, 3. All right, let's bring back 2 up 1. Back 2 up 1. Back 3 down 1. And then over 2 up 1. And over 3 down 1. Okay, so first of all, let's look to see if we have a function. All the x's are unique. So yes, we have a function. Is it 1 to 1? No, because the negative 1 is in there twice. So is the positive 1. But with quadratics, remember, they're not going to be 1 to 1. So let me try to get a nice graph through these points. It's close. Wonder if I could. Nope, I can't. So I'm going to freehand it. It won't be as pretty, but it'll be a parabola. So it's going to come down this way and this way. So that is a quadratic. Notice that it does pass the vertical line test. You can put a vertical line anywhere through it and it will just touch once. But it is a second degree equation. And I'll tell you what, let's go ahead and practice. No, let's not with the graph. I started to say let's go ahead and write an equation, but I don't want to push the needle too much. So this was number 3.